Hi, everyone. So, what we're going to start today is the new unit on quadrilaterals. That's what that's supposed to say at the top. At the top, properties of quadrilaterals. So, we start off with learning about parallelograms and rectangles. We do those two together because they're both pretty easy, to be honest, and they have some similar properties. So we're going to start off, we'll come back to this. This chart is used to help you keep track of all of the properties because there's a lot of them. So as we go through each section, so we're going to do these two together, parallelograms and rectangles. Then we do squares and rhombi together. And then we do trapezoids and isosceles trapezoids. So we'll come back to this at another time. I'm going to start this. We usually, if you are in class at all when we do one of these lessons, I usually have you like draw in the diagonals, which are like the lines if you connect the vertices. And I usually have you measure everything and I have you guys come up with the properties. But since you're at home, I'm going to give you some notes. I don't usually use these notes for honors because they're very basic. I usually use these for lower level classes, but I figured at least it'll give you an idea of what's true about all of these. So first up at the top, we can define what a quadrilateral is. I think most of you probably know it, but it's a four-sided figure. So that's what a quadrilateral is. And like I already said, we're going to talk about parallelograms, rectangles, squares, rhombi, and trapezoids. There's not really too much to this unit. It's a pretty short one because honestly, most of the standards that we're going to do, most of the properties that we're going to learn, you should have already learned in honestly elementary school these days. So most of it is just a review. There's just one section of quadrilaterals that is a high school standard, and it's when we work with coordinates. And I call it coordinate tests, which we'll get to later. So first, we just kind of do an overview of everything. So let's talk about parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. That's why it's called a parallelogram. So just to talk about the parts of a parallelogram, but these actually apply to all quadrilaterals, like what vertices are, opposite sides, all of that. So if I wanted you to list the vertices, obviously it would be like the corners. So M, A, T, and H would be the vertices here. If I asked you to list the opposite sides are across from each other. So MA and HT would be a pair of opposite sides, and then MH and AT. That would be the other pair of opposite sides. Opposite angles are ones that are like diagonal from each other. Now, the reason why we're going through this is because when we talk about the properties, I refer to opposite sides, opposite angles, consecutive angles, stuff like that. So it's good to know what they are. So H and A would be a pair of opposite angles, and then M and T would be the other pair of opposite angles. Consecutive angles. So think about consecutive interior angles, right? If this is parallel to this with this transversal and this transversal, if you remember consecutive interior angles from earlier in the year, M and H would be consecutive, A and T would be consecutive. Also, we have this line parallel to this line with these transversals. So M and A are consecutive, H and T are consecutive. So there are four pairs of consecutive angles in a parallelogram. So you have angle M and angle A and angle T and angle H, and then lastly angle H and angle M. So those would all be considered consecutive angles, and you'll see there's some properties with consecutive angles. The diagonals. So the diagonals of a quadrilateral are when you connect the vertices. So if I were to connect M and T, that would be one diagonal. And then A and H. So those are the diagonals. M, T, and HA. There is a symbol for quadrilateral. It's like not for quad. This is the symbol for parallelogram. It's just like a mini little parallelogram. This is the only one that has a symbol as parallelogram. And so when you name a quadrilateral, this actually, I think I've talked about this before. This came up on your last quiz in chapter 7, or I don't know, a couple quizzes ago. But when you name a quadrilateral, you have to start at one corner, say M, and go in either direction, clockwise or counterclockwise, without skipping around. You have to go in order around the figure. So like from M to A to T to H. I can't go M, A, H, T. You can't skip around. So you would go M, A, T, H, or M, H, T, A. Or you could start at any of these. Like I could call it H, M, A, T, H, T, A, M, and so on. So name a quadrilateral. You start at any vertex and go around the figure without skipping around. Does that make sense? I think so. Without skipping any? I don't know. Okay. So you could put like the symbol parallelogram MATH would be one possibility, or we'll go with or instead of a comma. I could say MHTA, or like I said, there's other ones too. All capital letters, and put etc. because there's a lot of them. So that's just one way you could, or two ways you can name a quadrilateral. And that goes for any quadrilateral, not just parallelograms. Okay, so let's talk a little bit about some of the properties of parallelograms. So not only are the opposite sides of a parallelogram parallel, they're also congruent. Opposite angles are congruent. Consecutive angles are supplementary, so they add to 180. And the diagonals bisect each other, which remember means they cut each other in half. Ooh, this kind of is faded. So those are the properties of a parallelogram. I'm just going to do a quick example of those properties down here. Let me just... My printer did not print this very well. Okay, so say we have this one. This one has some things drawn in. So these two are congruent. These two are congruent. Opposite angles are congruent. So over here it says find the measure of angle X. Oh, not the angle. X is not an angle. Just kidding. The side X. So X is going to be congruent to this one, 15. So those would be equal. So this is going to be 15. So 15 centimeters. And we can say because opposite sides are congruent. Y is right here. Y and 55 are opposite angles. So those are congruent. So Y is 55 degrees. And then because opposite angles are congruent. W right here is congruent to this one, but we don't know that one. However, these two, or either these two, whatever, it doesn't matter, are consecutive, and so they add to 180. So 180 minus 55 would be 125 because these add to 180. So over here, we're going to say W is 125 because consecutive angles are supplementary. So then once this one's 125, this one's going to be 125. Okay, if we draw in the diagonals and label the intersection point B, which segments are congruent? So I'm going to draw them in with a different color. So they'll blend in. So if I were to draw in the diagonals here and label the intersection B. So I said in this last theorem, the diagonals bisect each other. So that would make MB congruent to BT, and then HB congruent to BA. So we can add that down here. So we can say MB would be congruent to BT, and then HB would be congruent to BA because diagonals bisect each other. Remember, bisect just means cuts in half, right? Diagonals bisect each other. Okay, so that's pretty much it for parallelograms. I mean, the practice that you're going to do, I left it downstairs, but you know, you're given like maybe consecutive angles, so you have to know they add to 180, or you're given opposite angles, so you have to know they are equal. So it should be pretty straightforward. This is a really basic example. Like I said, the ones that you're going to do are like a little bit harder, but not much. So there's that one. I'm also going to talk about rectangles. So rectangles, for the definition of a rectangle, I'm going to say that it's a parallelogram with 4 right angles. So that's one way you can describe it. This theorem here gives it a little more specific. If a parallelogram is a rectangle, then its diagonals are congruent. So basically, a rectangle is a type of parallelogram. So we're squares, so we're rhombi. Those are types of parallelograms. So like parallelogram is like the broad term, and then rectangles, rhombi, and squares are like the more specific, like under that parallelogram umbrella. So one difference between a rectangle and a parallelogram is that rectangles not only have all of those other properties that we just learned that a parallelogram has, so it has all of those, but also it has 4 right angles and diagonals are congruent. So I'm just going to label right here like what's true about a rectangle, because there's kind of a lot. So it has 4 right angles. So that's the first thing about a rectangle that's not true about a parallelogram. And then the diagonals are congruent. Since it's a parallelogram, the diagonals also bisect each other. So these 1, 2, 3, 4 segments are actually all congruent. In the parallelogram example, it was just these 2 are congruent to each other and these 2 are congruent to each other. But because the lengths of the diagonals themselves are equal, then all the little ones are equal. So all 4 of these would be equal. Then just like all that same stuff about parallelograms is true. So the opposite sides are the same, which you probably already know this, but that's okay. Opposite angles are congruent, obviously. 90, 90, 90, 90. Consecutive angles are supplementary. Those add to 180. So now we can label some of the other stuff inside of the rectangle. Do we notice how these 4 triangles are isosceles? Right? Like these 2 kind of look the same and these 2 look the same. They are the same. They're congruent. So here's why. If I were to mark this one and try to figure out which one is this equal to, well, this is an isosceles triangle, right? So the base angles are congruent because of the isosceles triangle theorem. But then this, I should also have marked before that these are parallel. Whoops. So the opposite sides are congruent and parallel. Okay, anyway, so this and this are alternate interior angles, right? Because these are parallel. These lines are parallel. So this one's congruent to this one, and then this one's congruent to this one. So what happens is these 2 triangles end up being congruent. So these angles are congruent too, just to each other though. So you have one pair of congruent isosceles triangles, and then these end up being a pair of congruent isosceles triangles. So like 1, 2, 3 is congruent to 1, 2, 3 because it's isosceles, congruent to that one and this one. And then these 2 vertical angles are going to be equal. So kind of a lot happening with rectangles. You can use this to help you when you have to solve some of these problems. I'm not really going to fully do out these problems because I feel like they're pretty easy, but I'll just talk about like how you would set them up. Of course, my diagonals did not print. Don't know why. Hopefully that doesn't happen for you. These are supposed to all have diagonals drawn in, I'm pretty sure. So if you look at this first example, it says AC, so that's this one, this whole thing is 4x minus 60. And then BD, this whole thing, is 30 minus x. So those are the diagonals. So you would just set them equal to each other. So 4x minus 60 equals 30 minus x. And then you would just solve for x. Like I said, I'm not going to solve all these. You guys know how to solve equations. I don't want this video to be 8 hours long. So I'm just going to go through and show you how you would set them up. Okay, let's look at this one. Okay, so it says AR, this piece, is 2x plus 3. BR is 12 minus x. So look at the pieces we're given here, those two. Going back to this, all four of these are equal in a rectangle. So these would just be equal to each other. 2x plus 3 equals 12 minus x. And then you would solve. Okay, let's look at this one. Okay, BAC is 4x plus 5. So BAC, that's that one. And CAD is 5x minus 14. So you want to think about, like, what do I know about these two? A very common error for a problem like this is kids will set them equal to each other. They're not equal to each other in a rectangle. These are not equal. But we do know that this whole thing is 90. So they add to 90. So you do 5x minus 14 plus 4x plus 5 equals 90. And then solve. There's that one. And then let's take a look at this last one. Okay, so it says BAC is 3x plus 5. ACD is 40 minus 2x. So sometimes they'll give you like alternate interior angles like this. These are congruent, remember. So you would just do 3x plus 5 equals 40 minus 2x, and then you would solve. So this is what the problems are like for these sections. Basically, you are given some information about a picture. You want to label it. Think about what you know is true based on these properties, and then set something up. The last thing I want to do for you is fill in the two columns of this chart. Now, you can fill this in however you want. I like to fill it in with a check if it's true, and then I like to leave it blank if it's false. Some kids like to write yes, no, check, or X. This is your thing. So like, even if you want to put like little notes in over here, like whatever you want. So parallelogram, let's do that first. Opposite sides are parallel. Opposite sides are congruent. Consecutive angles are supplementary. Opposite angles are congruent. Diagonals bisect each other. So that's what we said was true about the parallelogram. Now a rectangle is a parallelogram. Not all parallelograms are rectangles, but all rectangles are parallelograms. So that means under rectangle, we can check off all that same stuff because it's true. On the notes that we just did for rectangles, I said that the two extra properties that a rectangle has is that diagonals are congruent and that it has 4 right angles. That's what we mean by 4 right angles. We mean the corners. So if you wanted to like draw a little picture, that's what we mean by 4 right angles, the corners. So that's what you should have checked off for rectangle and parallelogram. And like I said, next class, we will add on to it, and we'll add on and do squares and rhombi. So that's it for this lesson. Hopefully it's enough for you to be able to do the practice. If you have questions, as always, email me or you can come for ACLAB. All right, guys, that's it, and have a great day.